Okay, sixth grade, I am on page 380 in the workbook, and I'm looking at the top regarding rational numbers. I wrote down the definition of a rational number. It is right here. Numbers that can be written as fractions. Now I want you to pay attention to page 380 because this you're going to need to know for your test when that comes up eventually. Notice you have whole numbers. Your whole numbers are your counting numbers. Your integers are your positive, your negative numbers I should say, and the rational numbers by definition are numbers that can be written as fractions. Negative fractions, decimal 8, as you know, is known as 8/10, and you reduce it. 5.2 is known as 5, and the repeating 2 as a fraction, this is a mixed fraction right here, and this is a negative mixed fraction here, and this is a positive mixed fraction here. So this chart, you'll need to keep an eye on it because you may see it again for your test when that happens. Not today, not tomorrow, but it'll happen within the next couple of weeks. I then want you to pay attention to this, and I wrote it in my notes, so I want you to look and follow through with my notes. The first example talks about 3/10. That's the fraction. You know that if you say the fraction correctly, you can write it as a decimal. 3/10 is known as 0.3. Notice though, and you guys have said you can put 5 million zeros behind any number because it has no value, but these zeros are repeated decimals right here. This is the repeating decimal. It's a repeating decimal because all the zeros forever can be going on. But because zeros have no value, I can go ahead and cross them out. And when I cross them out, it's known as terminate the decimal. You get rid of all the zeros at the end. You don't need them. It's just 0.3. Another example on the table, if we go back, I'm now looking at the 5/6. 5/6 right here, if I write it as a decimal, is known as 0.8333. Notice that the 3's are repeating decimals. 3's keep going on forever. If this 3 is going to go on forever, I can't cross them out. That means that they do not terminate. The 3's do not terminate. They're never ending. But then we get into the definition of bar notation. And bar notation is a bar that is placed over the digits that repeat. In the example, 0.5454, notice that if I continue to write 545454 forever, my 54 keeps repeating. So I plant a bar notation over the 54. In decimal 5833, the 3 keeps going on forever. So I just plant a bar notation over the 3. That means that I'm making that 3 stop. That's what the bar notation means. On page 380, I did some examples with you under the got it. The first one was known as letter A, 1/6, cowboy horse who goes inside the house. The 1 goes in, the 6 is on the outside. I planted a decimal, and I did the math. Notice I stopped at the 4 right here. Okay, so this 4, I can keep on adding it, and then I got to bring down, and then do another 6 and so forth. I stopped after the second 6. When I stopped after the second 6, I planted a bar notation over that first 6 because the 6 is going to keep on repeating. In the second got it problem, 8/9, I did the math again, cowboy horse, and notice that the 8's keep repeating. I don't need a bar over both 8's, just a bar over 1 8 because the 8 kept going on and on and on. On the bottom of page 380, I did the got it where you have negative numbers. -1/4, I did long division, cowboy horse, I made it a -2/5. There it is. No bar notation is needed because at the end of that 5 I can plant a 0. And if I plant that 0 at the end, which I really don't need, this 0 means it is a terminating decimal. Terminating decimal, I don't need it. Under letter F, under the got it, it said to change -2 1/6 to a decimal. Well, before I needed to do that, I needed to take the -2 1/6 and I needed to change it to a fraction. And how do I do that? I have to go ahead and put the multiplication symbol between the 2 and the 6, and then add the 1. So this gave me -13/6. I did long division, and notice that as I kept going, you see all my arrows there, kept on dropping zeros, that 6 kept repeating. Here it is, 6, 6, 6, 6, 6 all the way across. So when I did the math, and I wanted to stop with that 6, I went ahead and wrote -02.16. I went from all these 6s that can keep on going to stopping it, and that's my bar notation.